Hello guys, this will be a tutorial for how to do t-test for uncorrelated means. Forgive me for the back noise and if you can hear it, because we have construction at the back of the house, so please don't mind it. Um, like I said, this will be a tutorial for uncorrelated means. So, these are the formulas that we're going to be using in order to have our answer. So, the formula for the t is mean 1 minus mean 2 divided by square root of v1 divided by n1 plus v2 divided by n2. And our formula for v1 will be the summation of x1 minus mean 1 squared divided by n1 minus 1. And same thing for v2, summation of x2 minus mean 2 squared divided by n2 minus 1. So these are the meanings in the right side of the laptop right here. So mean 1, the first group, mean 2 is the second group, and v1, v2, n1, and n2. So we'll have our first example. So step 1 is to formulate the null hypothesis, or the HO. So our example 1, the HO is there's no significant difference between engineering and computer science. So step 2, engineering is x1, which is, you can see here, and computer science will be x2. Step 3 is add all the numbers under x1 or engineering same as x2 or computer science. So you have to add all of these. So for engineering x1 is equals to 596 and computer science x2 is equals to 627. This is the summation of all these numbers. For step 4, count all the numbers on x1 and x2, and that will be your n, your population. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is, it says here, n1 engineering is equals to 10. So same thing for computer science is 8. So once you have all those variables right here, 500, the summation in their population. Next, hold up. Okay, I'm sorry. So step 5, you will divide your x1 to n1 to have your mean 1. Sorry. Okay, so once you have it, you will divide it and that will be your mean 1. So this equals to this. I'm sorry. The laptop is bugging out. So yes, once you have that, so your mean 1 will be 59.6 and your mean 2 will be 78.38. So step 6 is to subtract your first number in x1, which is 50, to your mean 1, which is 59.9, to fill in the next column. So 50 minus 59.6 is equals to 9.6, which is here. So as you remember, our mean 1 is the one divided by your population and your summation. So for engineering, that will be 59.6. So you do that with all of these. Continue this, yeah, as it says here, continue this until all column is filled. The same process will be done for x2 and mean 2. So same thing here. You'll divide it, you'll minus it by your mean for mean 2. So 70 minus 78.38 is equals to negative 8.38. So you continue that until you reach 65. So step 7 is the answers on the column x1 minus mean 1 and x2 minus mean 2 will be squared. So you will square all of these until you're done, if I'm correct. 96, negative 9.6 squared is equals to 92.16. Continue that with all of the numbers, same thing to x2 minus mean 2. So once you're done, it will look like this. So the summation plus and then the population, you'll get that. And then after once you got all of these, you'll square it. So after you square it, you will get the summation of it. So the summation of x1 minus mean 1 squared is 15,000. Oh wait, I'm sorry, 1,598.4. And the summation for x2 minus mean 2 squared is 517.84. So this will be our solutions. So as you remember in the first slide, these are the solutions for V1 and V2. So you put the answers that you have a while ago and substitute it for that, and complete this process. So V1 minus 1. So you just complete this process until you get your final answer, which are these solutions again. This is for C. So these are the means that we got a while ago, and substitute, everything will be substituted, so you'll get your final answer. After that, we'll do our DF. So remember a while ago, our N1, which is our population. So engineering was 10 and computer science was 8 minus 2, so it equals 16. And we have to do the percentage, the TV, which is 1%. So NTV is 2.583. So this is our decision. The HO is rejected because CV is higher than TV. There's a significant difference between engineering and computer science. So if you see our TV, this is 2.583, and our T is only 3.61. So there's a significant difference. Okay. All right. Now is our example 2. So step 1, same thing, formulating null hypothesis. There is no significant difference between traditional and simulation. So these will be our numbers that we'll be using for this example. So as you can see a while ago, they didn't have an equal population. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're both 10. So same thing, traditional is x1 and stimulation is x2. Add all the numbers under x1, blah 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 blah. Same thing. So you have to add all of these, and x1 is equals to 299, and x2 is equals to 320. Count all the numbers in x1 and x2. That will be your population. So that's the only difference. So they're both 10. Divide your x1 to n1 to have your mean 1. Same goes for x2 and n2. So the same thing, divide it, and then you get your means. So technically, these they're just back and forth. So it's all the same thing that we did in example 1. And then same thing, subtract your first number in x1, which is your 30, to your mean 1, which is 29.9, to fill in the next column. So 30 minus 29.9 for our mean 1 is equals to 0.1. Continue this until you fill up